Hi everyone, today we are looking at transformations of sinusoidal functions, okay, and we're going to look at graphing them today, which is section 5.4. Okay, so we'll start off with the base functions. So they look like either y equals a sine k x minus d plus c, or we have the cos in place of the sine. Okay, notice here that whatever within the brackets is always in common factored form. If it's not, you have to common factor out the k value, which is the value that multiplies the x. Okay, so just recall that the a is the amplitude. Okay, also the vertical stretch factor. K is the horizontal stretch or compression, and the period is equal to 360 divided by K. Or we can rearrange it, multiply the K up. So we get K times P is equal to 360. So then K would equal 360 degrees divided by the P. And this comes in handy when we're trying to figure out the equation given a graph. Okay, and D is our phase shift, and C is our vertical shift. All right, so with all the sketching we do, we're only going to sketch one cycle, okay? Because if you're asked for more, then you just continue the pattern, right? But it just makes it for a longer grid. So first one here, amplitude is equal to 2. Period is equal to 360 degrees because the number that's multiplying the x is just 1. The phase shift is right 30 and the vertical shift is up 1. Okay, so the way we're going to graph these types of functions here, remember we did in chapter 2, we actually took base points and we applied the transformations to them. We're going to do a little bit differently for this section here. And we're going to do it in 2 steps. So the first graph we're going to draw, we're going to ignore the horizontal shifts and the vertical shifts. We're only going to consider the stretches or compressions. So this one here is y equals 2 sine x. That's what we're going to graph first. Okay, so we're going to graph y equals 2 sine x. And once we do that, we're just going to shift it right 30, every point right 30 up 1, or the 5 key points. Okay, so remember a sine curve. Right, it starts there at its equilibrium. It ends at 360. Okay, in this case because the period is 360, and then halfway between it's at 0 again, and then right in the middle it's going to go to its max, and right in the middle here it's going to go to its min. Okay, so these are the 5 key points. You always have your intercepts and your max and mins. Those are your key points, okay? Intercepts and max mins, and you're always going to have 5, regardless if it's sine or cosine function. Now, we're going to take each of those points and we're going to apply our shifts. Okay, so we're going to shift each of these 5 points right 30 degrees and up 1. Okay, so we look at our scale, and our scale, we're actually going by 60s, right? So we have 180 divided by 3. So we're going by 60s, so half of that would be 30. So this point here is going to go to here. Oh, sorry, and then we're going to shift it up 1. So we're going to do those 2 steps in one. So we're going to go right 30, up 1, plot a point. We're going to go right 30, or sorry, up 1. Again, I'm going to get my scale right there. It is. That's 1, right? Right 30, up 1. Right 30, up 1, right 30, up 1, and right 30, up 1. And then we simply sketch. And that is one cycle of this function. And that's it. Okay, so 2 steps. All right, next one here. Amplitude is 3. The period, the k value is 2. So the period is 360 divided by 2, which is 180. And we have no shifts. Okay, so this one right here, again, we'll plot our first point. I like to do our end point, or sorry, is at 180 now. So 180, and then right in the middle, we go back. So there's our first 3, and then we're going up to 3. Okay, and we're just going to approximate it, right? Because we don't know exactly, so about right there, and in the middle here, down to 3. And there's one cycle. You put arrows at the end to indicate that it keeps going. Okay, excellent. Okay, now we have a cosine curve here. So the amplitude is 3. The period is 360 divided by k, which is 1/2. So we invert and multiply, and we get 360 times 2 over 1, which is 720 degrees. And it's a cosine curve now, so this one's different. So cosine, remember, has its maximum on the y-axis. So we're going to plot the first point there, and then it's going to get back to this point after one complete cycle, which is over here. And then the halfway point, which is at 360, it's going to get down to its minimum, which is at -3. And then halfway between the 360 and the origin is 180, and that goes your intercept, and then it goes your other intercept. And there is one cycle of the cosine curve. Okay, now this one right here, we're applying pretty much all our transformations. So the curve we're going to sketch first, we're going to sketch y equals 2 cos 3x, okay, because we're going to graph our vertical and horizontal stretch and compression. And then after we draw this, we're going to move each of the 5 points right 30 and up 1. Okay, so it's a cosine curve, so the amplitude is 2. The period is 360 over 3, which is 120 degrees. Okay, so for cosine, we're going to go to 2 there, and then at 120, we're going to go to 2, and at 60, -2, and then 0 and 0. Okay, those are our first 5 points. And now we are going to move each point right 30 and up 1. And if we notice my scale, it goes by 30s. So we're going to go right 30, up 1, right 30, up 1, right 30, up 1, right 30, up 1, right 30, up 1. And there is one cycle of a cosine curve. Okay, and again, it just continues on in both directions. Perfect. All right. So the next examples, we're going to determine the equation from a graph. And actually, this is more important because what we try to do with this stuff is we collect data, right? We collect data and then we model it. So we draw a curve through it, and then we try to figure out the equation of the curve. Now, once we have the equation, we use that equation to make predictions. Okay, so for future values. All right, so this one right here, we can model this with either a sine or a cosine or both, right? They're gonna get the same thing. So in this case right here, because its maximum is on the y-axis, I would use a cosine curve because it's in phase. Okay, there'd be no phase shift. But I'll show you what it'll look like for a sine curve as well. All right, so what we're gonna do here is we're gonna pick off our characteristics. We're gonna start off with our amplitude. Okay, so the amplitude is from the middle of the graph to the highest point, or the middle to the lowest point. Okay, or you can do the max minus the min divided by 2, and that works as well. Okay, your maximum y minus your minimum y divided by 2. All those formulas work. So in this case here, the amplitude is equal to 3. And if you want to use the formula, it would be 3 minus -3 over 2. That's 6 over 2, which is 3. Okay, good. Now, for our period, the easiest way to find a period I find is just locate a max and locate another max, and then find the horizontal distance between them. So in this case here, it's 720. So the period is 720, but for the equation, we need the k value. So that means that the k is equal to 360 over 720, which is, in lowest terms, 1 over 2. Okay, now if we're doing a cosine curve, there is no phase shift because the maximum is on the y-axis. And also, there is no vertical shift because the graph is symmetrical about the x-axis. It hasn't been shifted above it or below it at all. But to get the vertical shift, right, if you're given data, for example, you would use the formula of the max y value plus the min y value divided by 2. Okay, so in this case right here, it would be your max is 3 plus your min is -3 over 2, which equals 0. So a cosine function would look like this. Y is equal to 3 cos x over 2, or 1/2 x. Okay. Now, the only thing that changes, if I said, okay, model this with a sine function, the only thing that changes would be the phase shift, or the horizontal shift, right? So in order to do a sine curve, what you would do there is you would find its equilibrium point, right? So you're thinking, okay, well, wait a minute, I have 3. I have 1 here, 1 here, and 1 here, and 1 here, right? But you want to take the one that, I like taking the one that's closest to the y-axis, and when the graph is increasing to the right of it. So in this case here, it's increasing. Here, it's decreasing, so we don't want this, right? So we'll look at this. So what happened was the sine curve has been shifted left 180. So if I were to write a sine function, it would be y equals 3 sine, and then I would do 1 over 2 x plus 180 degrees. Okay, so if I plugged the first function into Desmos and the second function to Desmos, it would be the exact same curve. Okay, they would overlap each other. All right, now for this one right here, okay, it looks like we do have a shift because it's not symmetrical on the x-axis. It's actually been shifted down, right? So the amplitude, a little bit harder to figure out, but again, you just take your max minus your min divided by 2. So the max value is at 3, and your min value is at -5 over 2. Let's get rid of that there. Okay, divided by 2, which is 8 over 2, which equals 4. So that's your amplitude. For a sine curve, the equilibrium value okay, which is at -1, because from -1 to 3 is 4, and from -1 to -5 is also 4. So this is your, you can even draw a line, the line of symmetry there. Okay, so the phase shift for a sine curve is none. The vertical shift, okay, is equal to -1. Okay, again, you can use the formula max plus min divided by 2. Okay, so you have 3 plus -5 over 2, which would be -1. And now we are looking at our period. So we're going from equilibrium back to equilibrium, if you want, is 180, or you can go from here to here and also determine that it is 180 degrees. So the period is 180, which means the K value is 360 divided by 180, which equals 2. So for a sine function, we have y is equal to 4 sine 2x minus 1. And you can put that in brackets if you'd like. Okay, now if it were a cosine function, okay, one equation that would model it is y equals, so again, the 4, the 2, and the -1 stay. The only thing is a phase shift. Now all you do is you locate where a maximum is. The one I like to do the one closest to the y-axis, so it would be this one right here, and it is to the right 45 degrees. So that would be your phase shift. So it would be 4 cos 2, and then it went right, so it's going to be minus 45 degrees minus 1. And there's your work for this section.